So now we can come back to our example 1 here and determine our margin of error. Let's do this for a 95% confidence interval, so 95% confidence level. So our margin of error for a 95% confidence interval is going to be 1.96 times the standard deviation of the p-hat distribution. And we don't know the population proportion, so this standard error then is going to be, so this would be 1.96, and this will be the square root of p-hat, 1 minus p-hat over n. So for us, that's 1.96, and then our p-hat is 0.28, so square root 0.28, 1 minus 0.28, and then divide by 1124 is our sample size. And then if you evaluate this on the calculator, this standard deviation or standard error, you get 0.013. You multiply that by 1.96, and this is approximately 0.026 to 3 decimal places. So then our interval, our confidence interval, then is going to be p-hat plus or minus that margin of error, 1.96 times sigma p-hat. So 0.28 plus or minus 0.026. So if you subtract 0.026 from 0.28, you get 0.254. And if you add it, you get 0.306. And we are 95% confident, 95% confident that P is between 0.254 and 0.306. And that 95% confident again means that, well, 95% of the intervals generated will contain the population proportion. And what we notice here is that 0.25, 25%, not in that interval. And it should be 95% of the time. So notice that 0.25 is not in the interval. 0.254, it just misses to 0.306. So the answer to our question here, is it possible that less than 25% believe they paid too much? Well, 95% of the time this should contain the true population proportion. So is it possible that the true population proportion is 25%? It's possible, but not likely. So there would only be a 5% chance that the population proportion would not be in that interval. So only 5% of the time. Does the interval that we generate not contain the population proportion?